Yeah, come on.
There was supposed to be another guy here called Andreas Arledal. I met this guy actually yesterday at the speaker's dinner. He was sitting right next to me. Apparently he's ill now. There's a good part and a bad part to that. The bad part, of course, is that I might turn ill within a few hours, and I won't make it till tomorrow's conference day. The good part is that we actually discussed some of his content. He was talking about, yeah, I'm going to give this talk tomorrow on JavaScript beyond jQuery, and I was able to actually use some of that conversation 3.5 hours ago when I got told, could you do this presentation for us instead of Andreas. So I spent the last 3 hours mostly translating stuff that I had in Swedish before. And I've kept the title. I hope I can live up to what Andreas wanted to talk about, but of course with a slightly different Johnish angle. So let me start with this URL. Have you been visiting this URL? Let's check it out. Let's check it out. I hope my network is working here. There we go. It's a good one to start with. So whenever you feel doubtful about learning JavaScript, you can go to this URL, or you can tell your friends and teammates. You could also actually look at the source. Let's look at the source. And in here, it says, seriously learn JavaScript and not just jQuery. And please don't use w3schools.com as learning material. And actually, I'll come back to what you should be using as a reference material instead. So that's a good start. But I would actually like to go into some details right away, and I will be comparing JavaScript with Java. So hopefully this will be something familiar, and then we can look at the differences there are. First of all, types. In Java, you have a lot of primitive types: byte, short, int, long, float, double, boolean, char. And the rest is objects, or so-called reference types. If you compare this to JavaScript, you will find that you also have a bunch of primitive types, and the rest are what's called objects. And in JavaScript, some of these are more specific that we need to look into. So string is not a general object of some class string. It's actually a primitive type. So string is one of the native primitive types of JavaScript. The next thing to know is that JavaScript has only one type for numbers, called number. So it doesn't matter if it's an integer, and there's definitely nothing like unsigned int or something. It's just numbers, all of them. And this, of course, is a potential hazard because of the floating point problems that we see sometimes in programming, rounding errors. They can always happen in JavaScript because there's no way to get away from decimals. You can always have decimals here. The third one to mention is that functions are full objects with their own type. This means that functional programming is something you can definitely do in JavaScript. You do not need a class where you put your functions or methods inside. So this means that verbs, like doing something, can float around on their own. They don't need a noun that they're attached to. So functions are living in the global space, namespace. And then we need to mention undefined, which is JavaScript's version of something that's uninitialized. There is also null, which is a value that a variable can have, but undefined is a specific primitive type. Going further into typing here. So in Java, in the top box here, we have static typing. And this should be familiar to all of you. So variables have types. We declare variables with a static type, in this case string, and then the identifier of the variable. Values also have types in Java, which means that we can do a static type check to make sure that the variable the type of the variable matches the type of the value. So the third example here in the Java box that's crossed out means that we cannot assign variables of a different type to values of a type that differs from the variable. So in this case, name is a string, and therefore it cannot contain something of the value integer. JavaScript, however, has dynamic typing. This means variables do not have types. Let me repeat that. Variables do not have types. Values, however, have types. This means that you can assign something of the value string to the variable name, and then later assign a number to that variable. And what dynamic typing means is that the variable actually switches type dynamically. So this is the JavaScript case. You can have a variable name, it has no type, but values have type, and the variable will switch to whatever type its value currently has. Then we have strong versus weak typing. And this is a kind of a special case because these words have some typical meaning in natural language that's not really true in programming languages. So strong does not mean good, and weak does not mean bad. If you have a programming language with strong typing, that doesn't mean that it's any better in typing. It's just a version of type system. But you typically hear people being really proud of their strong typing, and then people we have weak typing? Let's just say it's just two versions of typing. So, looking into strong versus weak typing here. Java on the top again. So, we declare statically that the int var has the type, primitive type int, and we assign it a value of 4. And in this case, we will have be sure that int var is still of the type int. But if we now add this to an empty string, we actually have what's called an implicit type conversion, and we will get a string back. And this is a case where you actually would say that Java doesn't have really strong typing, because how can we possibly use an operator for two values of different types and then get one of those types in return? This is implicit type conversion, and it's typically not found in really strong typing languages. We can also have what's called implicit widening type conversions. So if we add an int to a float or a double, we will get a double back. So we're widening the scope of that variable. And we, of course, have explicit type conversion, where you as a programmer need to tell the compiler, I want to do a type conversion here. So that's the int in parentheses. But some kind of operations, for instance, adding null to an int is not allowed. So that's where the strong typing system in Java kicks in and says, this is not a valid statement, I cannot figure out the type of this. And it's, of course, because maybe this, actually, I should ask you, I'm a front-end developer these days. Would auto-boxing kick in here and convert that int var to an integer with capital I and then actually allow? No. Okay, I'm still good. Whew. Might have lost it there for already at slide 5. Let's look at JavaScript. We can here declare a dyn var and assign it to assign the value 4. And JavaScript is known to have a very weak typing system. Again, that doesn't mean very bad typing, it just means very weak. And weak in this case means that you can get type conversions implicitly almost all the time. The typing system will try to figure out whatever you do, it will try to come up with some type, and this seems to work. Let's go with this one. So you can add a string to that dynamic variable that you had 4. You can add null, you can add an empty array, you can add an array with a value of 0. All of these are possible. We should actually try. These are possible. We should actually try to do it. I usually use Firefox Firebug, but I cannot increase the font size of the JavaScript console anymore. This is a bug in Firebug. So if I increase, you can see here, if I increase this, everything else is increased, but not that one. So kind of sad. But let's at least do this and see what we get back. So first we declare it. We assign the value 4, and then we add an array with one element of 0 in there. And we get 40 back. This is the weak typing system kicking in. It tries its absolute best to find out a type that will work for what you did as a programmer, to save you. So this is weak typing, because we don't have static typing to figure out what it should be and give you a compile error. So we need to try to avoid errors. Which brings us to, there we go. So we mentioned dynamic versus static typing. We mentioned weak versus strong typing. And together we can now reason a little bit about type safety. Type safety is all about not producing type errors runtime. And you need to figure out a combination of dynamic, static, weak, and strong so that you avoid type errors in runtime. And that's why JavaScript is trying to figure out all these crazy things, that if you add 4 and an array with an element of 0, it becomes a string of 40, is to avoid a runtime type error. And that's the typing system trying to bring you type safety. So my conclusion of this is that Java is a statically, strongly typed language with decent type safety. And JavaScript is a dynamically, weakly typed language with decent type safety. This means that you don't have to be worried about this. Weak and dynamic is okay. You can produce Turing-complete programs with this language. Next topic, object orientation. This is, of course, part of the typing, because you introduce new types with classes in Java. So typically in Java, you will find that your source code produces a lot of classes. Some of them you will produce several instances of, such as beans, in your executing code, which is on the right side here. And some of them you will produce singletons from. But you always produce these class files. And the relation between source code and runtime execution is that you write your classes, and then in runtime you have instances of them in form of objects. In the JavaScript case, you still have some method of inheritance, and it's done through something called prototyping. So every object has a prototype, and you can extend the prototype. But as I mentioned earlier, functions are also they are standalone. You can have functions on their own. They don't have to be in some kind of an object or class. Which means that in your source code, you will find both prototypes for carrying around data and functions. And in your executing code, you will have instances of these prototypes in the form of objects, and you will have these functions that you can call from the global namespace. And if you look at typical JavaScript code, you will see that people don't actually use these prototypes as much as you would think they would, because this is an object-oriented language. Instead, functions play a major role in JavaScript. And you see them in the form of anonymous closures and so-called modules. We'll see what that means in a while. Just to show you what this means in real code, this is some statistics from keywords in JavaScript. And the statistics are taken from the jQuery library, jQuery mobile, a widget library, prototype, XJS, backbone, underscore. And what you see here is that people use the function keyword a lot. There's a lot of functional programming going on in JavaScript. You seldom see the new keyword. People are not instantiating objects from prototypes with a new keyword. That's not really a common pattern you see in JavaScript. You almost never see the keyword instance of, meaning that you're trying to check for is a relations between two objects. So this is the difference between Java and Java-like languages and JavaScript. Let's mention some more things regarding inheritance. So this is from way back when I was a teacher at Linköpings Tekniska Högskola, and I was trying to explain inheritance and its relation to extension and subtyping. So I came up with these two images. This is how it works in my head. So when we inherit in Java, we both do extension, which means that we're going from a superclass and we extend it with more functionality into a subclass. We're adding more stuff, perhaps even more state. But we're also subtyping, meaning that we go from a super type to a smaller subtype, and smaller in the sense of being more specific. So when we're doing inheritance in Java, we're expanding or extending functionality and state and being more specific and being smaller in terms of type. I just have a summary of that here. Through inheritance, Java classes get larger in terms of functions and smaller in terms of type, in the sense of more specific. In JavaScript, extension and subtyping are separate things. You can extend a prototype without introducing a new type. You can just add things, and it's still whatever it was before. It's an object with stuff in it. So you can, of course, do subtyping, but you very rarely see people do that unless they really need so-called is-a relations. Why do we talk about and want subtyping, especially if we come from a Java background, which I come from? I think it's because we think in terms of static typing and is-a relations. So, for instance, a student of computer science is a student. If we built an object-oriented system for handling students in register or so. So let's look at that. This is the Java case where we had some kind of public method where we can do a purchase of some kind of item. And when we think about this, we know that, okay, I can now call this method with an item or a subtype of item. And this is how we design our APIs in Java. So this method would accept item or subtypes of item. Let's look what happens if we move this into a JavaScript mindset. And here we have dynamic typing. So first, let's get rid of public. There's no access modifier in JavaScript. Things can be either public or private, and you will see how that works a little bit later. We can get rid of void. We do not have to declare any kind of type that we're going to return, and we definitely don't have to declare that we're not going to return anything. And then we get rid of the type of the input parameter. Now we're getting close to JavaScript code. We just add the function keyword to say this is a function, and this function accepts anything, dynamic typing again, any value could be bound to this variable item, or even nothing. It's okay to call this function without any parameters. Also, this function can return anything or nothing. So the code gets actually quite simple. And if you go into this mindset, you're not so worried about doing subtyping and wanting to introduce classes and relations between objects. Of course, doPurchase will have to look at item and check that certain things are in there to be able to function the way it's supposed to. But this is the power of dynamic typing, or one of the powers of it. Part 2, to start a JavaScript program. Sounds kind of basic, and perhaps it is. In a typical web application, you could see this kind of mixture, and we'll just go through this. So you see script tags here. And now we're talking about JavaScript, of course, in the sense of web. There's also server-side JavaScript, but that's another thing. So if we include a script tag referencing a file in head, this will be loaded synchronously and executed right away, as soon as it's loaded. We can also have script tags with inline JavaScript in the head tag. This will be synchronous and execute directly as the parser goes down, which means that this will be executed before there exists a DOM. We can also have JavaScript directly in HTML. And in this case, we're attaching it to the onClick event. So as soon as there's a click on this button, this JavaScript will execute or start. We can have script tags with inline JavaScript in the body of the HTML document. And this will be executed once the parser gets down to this place. So whatever has been declared and generated above in the DOM will exist, and below will not exist. And this will catch you a lot of times if you do inline JavaScript coding. For instance, if you have elements below that you try to manipulate. And last but not least, you can have references to JavaScript files in script tags in the body. And these will be loaded and executed synchronously. Now, the good practice here to get something that's maintainable is to keep all your JavaScript on files. And this is all about separating things. Separate content, style, and logic. So inline JavaScript is actually something you should avoid. And if you do static loading in the head segment or the body, might be because of some certain dependencies you have, but try to keep all your JavaScript loading or the static loading in one block, not spread out in your HTML files. It's much harder to understand what happens and in what order they happen. I mentioned static loading, which means that you have in your static file or in maybe dynamic HTML, but still you have a static reference to a JavaScript file. But it's actually possible to do dynamic loading, and you see more and more of this from JavaScript frameworks, that they dynamically load the JavaScript files that are needed for this certain view. The user has clicked through a few buttons and then suddenly needs some more code, and then that code is pulled in. And this is just some bare bones JavaScript to show how that could be done. So it gets the first script element from the current DOM. It creates a new script element, sets some attributes, for instance the source, and there's also an asynchronous attribute to set. And then it inserts that node into the DOM, and suddenly the browser will kick in and go and load that code. So this can be done at any time in your web application, and thus you can get dynamic loading of code. Okay, that's loading, but I actually promised I would say something about starting your JavaScript program. My first question, how many of you have written recently a static void main in Java? I just remember these were the great times when you were studying this language from the beginning and you thought that this is actually something you do on a regular basis. And in most systems I work in, and I used to work in for backend coding, I never got to write the main. I don't even know where it is because it's not in the application code. There's some kind of container that has the main function. So the equivalent of a main, which means that it will start executing your code, would be just a function statement right out in the global namespace, in this case the window some global function parenthesis. If this exists in a JavaScript file or inline JavaScript, it will execute right away when the parser gets to that place. Or as this is what's called a self-invoking function, and I will explain what a self-invoking function is. That's the JavaScript code on top there. Self-invoking functions, and this is not some esoteric thing. These are actually used a lot in JavaScript, so that's why I mentioned them. Self-invoking functions are wrapped in a parenthesis, as you can see, outside the function statement, which means that it will be defined and then executed right after it's defined. So this is also some kind of a main, or run this code directly. And just to show you two of these cases, they're both anonymous, meaning that I never give them any name. I just say this is a function and execute it as soon as you've parsed it and know what you're supposed to do. And this is a case where you can do more or less dependency injection. So you see I inject the name John into the self-invoking function myfunc, so that the local variable or the parameter me gets the value John. And the second example here is just a self-invoking anonymous function without any parameter. So you typically see code in files enclosed with this kind of code patterns, because you want the code to execute directly, but you want a local function scope. Moving into scope, part 4, variables. You typically do not want to clutter your global namespace in your applications. So if you declare a lot of variables outside a function scope, they will be globals. They will be attached to the window object. And a really nice, clear JavaScript application only has one global variable, or uses a framework that has one global variable. And then all your objects that you need for your applications are objects attached to that global one. And you could actually check this, and people do that on, for instance, code audits. What's the footprint of the application? Do they see one global variable? Good, tick, that's okay. Do they see 15 global variables? That's not good. The global variables are, of course, accessible from anywhere. So if you declare the glob here, it will be window.glob or just glob, because it assumes window for the global namespace. But as you can see, once you have your one global object, you can then say global.func and start defining functions. So you can just keep declaring things under your one global. And in that way, keep your global footprint very small. Interestingly here, if you see the difference here, in the for loop, I'm declaring a variable I, which will be my iterating variable, and I'm also inside the loop declaring a temp variable. A little peculiar thing that could really bite you in JavaScript is that there are only two scopes: full functional scope of your variable or the global scope. This means that even though you can write the code this way and it will work, what you've actually expressed to the JavaScript engine is this. All those variables will be in the full function scope, although you wrote them further down. So this is a difference from, for instance, Java. And it's called hoisting. All variables, no matter where you declare them, will be hoisted to the top of the function and exist there, which means you can get into all kinds of shadowing problems. And so the good practice here is to always declare your variables on top. Old C style, actually, if you remember that kind of thing. The one exception might be the I for the for loop, because typically you will not shadow that further down or so. But I actually try to declare even my loop variables on top, just to keep it into one var statement where I list all the variables I need for my function. I think the Swedish word for hoist, hala. So your flag, you're hoisting it. You're hoisting your variables to the top of the function. The next thing is that we have closures, typical for functional languages. So within a function, you have a closure. In Swedish, that's hölje. And inside here, once a value assigned to a variable gets inside a closure, it will exist for as long as that closure exists. So if you assign this to some kind of variable that's lives throughout your application lifespan, in this case, the array will still exist because it's inside the closure. And that's because the closure needs to function. So you cannot kill this because it's a local variable or such. We'll see how this works with the so-called Clockford module pattern in just a while. But I'd like to show you a typical pitfall that you can find yourself in when you're writing JavaScript code. And in this case, when you're doing things asynchronously, typically AJAX. So this is a snippet of code that's supposed to load some kind of page element. So we'll have to pretend that we know that the page element here is some kind of util package that has a load function where you can send in a page URL and go and load a snippet of a snippet of HTML, for instance, a small view to your application. And as you can see, this snippet starts with a for loop, so it's supposed to be somewhere inside a function. It's not living on its own. So this is just a snippet. And you might see here that we're declaring page inside the for loop. And by now we know, I should mention this first, I'm sorry. So the load function gets a page URL, then it's a comma. And the second thing is that it has a callback function. And this is typical for asynchronous calls. So in this case, it will go and load a page element over the network. It will leave the thread until it's done loading that. And therefore, you send in a callback function to say, when you're done loading that page element, do this. And in this case, launch a form and use that page element that you got back. So you see callback functions in asynchronous JavaScript. But going back to this page variable, you heard me mention that all variables are hoisted. So even though we declared it inside the for loop, it will, for JavaScript, actually be like it was declared outside the for loop. Which means it gets a new value for each iteration. The loop keeps updating to the next page to load. And when the callback, this is asynchronous, when the callback is run, page will now refer to the last of these values, or somewhere in between, depending on when this callback will actually fire. So this is a typical problem. You try to declare a local variable somewhere close to some asynchronous call, but it gets hoisted, and then you update it in a loop, and when you get the callback, you've actually overwritten the value you were supposed to use for the callback. And you will get all those forms will have the last page element. So you get a load of those. So in this case, you can use a closure, and this is just to show how things are bound to a closure. If you see the difference here, we are introducing a new function around the page element load. And you see it's self-invoking, and we send in the page from outside here. This means that in the function page, and then opens up a new scope for page element load, we now have a new function. And function is the one way to open up a new scope. You have the global scope and you have function scope. So now we actually get a copy of the page's current value inside that closure, which means that when this callback is run, it will still have the right value for page. Was it clear? The really tricky thing here is that you call the local variable in the closure function here, page, and then you send in page. And if this feels worrisome, you can of course do it like this. And then when you've done that a few times, you feel, no, I know about this, so I don't need to help myself. I know that I can have a local variable name as the one I used to send into the closure. But this is just to show that you bind values to closures, and the function scope is the only scope except for the global one. So if you need a copy of the value, you need to introduce a new function scope. Yeah, that's a comment for that. Okay, so now we have self-invoking functions, we have scoping, and we have closures. We are now ready for the most important design pattern, as I know at least. It's the so-called Clockford module, or the module pattern. And hopefully we'll go through this in steps. So let's say we're trying to build a cache here. And I actually think this is from a small system I wrote for the tutorial, where you were supposed to get patient objects to show what kind of medications a certain patient was on. And if you made a new call only within a minute, it will use a cached copy inside your browser. And then it times out, and every minute you go and actually fetch a new patient object. So this is just some pseudocode or some code to show how we could build that. If we run this, what will actually be inside jw.cache? I can say we're not done yet. This is not the full implementation. Undefined, good. It will actually be undefined because this is a self-invoking function that has no code, no parameters, and when it's done, it doesn't return anything. So we're still undefined. And a caching function that's undefined is not a very good caching function. So let's try to return something here. Now what do we have in cache? We actually have an empty object. This would be the same as actually saying are you with me? Because the function is self-invoking, so it runs immediately and returns an empty object, and that's what's being assigned to the variable. So we're still not really done with this cache. But we're moving towards this so-called Clockford module, and that's why I need to show this. Now we can actually return an object with an attribute that's a function. Now what do I have in the cache variable? Now I would actually be able to do this, right? Some kind of, do you know about this guy? Yeah. So-called Tolvan, standard test patient in Swedish medical systems. It's a correct Swedish personnummer. So, but you get me that we're returning an object that contains a variable getPatient that is a function, and we assign that to the cache variable. Now I introduce a variable, a local variable in the function scope. Will that variable, it's called cache, will it be available to us through the jw.cache? No, it's local. Will it be gone as soon as this self-invoking function has run? No, it's inside the closure, and the closure actually still exists because it exposed a function called getPatient. And getPatient, if it wants to access the local variable cache, that variable has to still exist within the closure. So we could keep working here, and we can, in this getPatient function, introduce a variable result that equals the cache, and we go and look. So this would have been implemented as an array with the cache. So all the patient objects that we've retrieved and that are still considered valid will be in that array. And we maybe check if they're still fresh. If they're not, we'll go and fetch the patient object with Ajax again. So this means, this is just to show how that code would work. We can keep doing this. We can also introduce function names in the closure that are local functions in the closure, and that we can use in the exposed function getPatient. So in this case, the getPatient function will be accessible through this object, but the getPatient function in turn can use the isValid, which is a local function in the closure. And we can keep coding here and actually implement a full cache. So this is checking the timestamp of what we found in the cache. So this means we can have closure private variables and functions. And now we're actually quite close to the kind of programming we like in object-oriented programming, which means information hiding, breaking things up into small functions that perform small parts of what we want to carry out, and only the public functions or the public methods we want to expose are in the return statement. So here where we expose getPatient, that's where we expose our API, and we can then break that getPatient function into small snippets that we keep as local functions. And this is what's called the Clockford module patterns. This is a way in bare bones JavaScript, a way to build modules that can have local state, local functions, and then just expose the things that we want to be public. And this is just to show the pattern of such a module. Was it clear? Yeah, good. Just a small one about named parameters. So let's say we have a public method in Java, execute purchase, and we run into this classic problems of not really introducing good new classes to make typing and reading of the code clear. So we have the signature of int string boolean user. I've seen such APIs and they don't really help me as a programmer. I typically need to go and read the documentation or even check the source code to know which string should go first and second. This is kind of nice in JavaScript because since we have dynamic typing, we will only say what the variables are. And they should typically not be var1, var2, var3. Instead, they should say what this is. So this would actually be more clear to programmers that use this function. Because here we would say price, item, discount code, wants spam, user. The boolean wants spam is actually from a project I used to work on. Then we have the builder pattern in Java. I don't know. Have you been using the builder pattern? It's still one of my favorites in the Java space. To make this more clear, if you need to start building up your parameters. So you introduce a builder and you set price, set item, set want spam, set user, and then a final .build. And this will actually build up the parameters that are needed to run this. But in JavaScript, you could actually just send in one object that has all of these things named inside them, which makes it super clear for the caller of the function, because now we don't need to have them in a specific order anymore. To call this function, you just need to open an object and make sure that somewhere in there you have a price, you have an item, you have want spam, and you have user. And you pass that into the function. So even for the builder pattern, it's very nice to see that you can work in a similar way in JavaScript. And this is my final part. And you see, we're moving into the black belt part now. I think I have about 5 minutes left. So this is asynchronous module definition with what we call Requirejs. When we have all of these module functions, the Clockford modules, it typically gets into a mess when we have them spread out in various files, which we typically want to have, not all of our code in one file. But we have dependencies between them. And that means they need to be loaded in a specific order. So this is just from the, I don't know, some of you might have been to the tutorial I gave together with Joachim Kemeny yesterday. And this is just for a small system for buying capsules, coffee capsules. You get into this amount of JavaScript files. So you can imagine a full-size enterprise project, how many JavaScript files you get. And when you build and go into production, you typically concatenate and minify all of that JavaScript into one JavaScript file. And it will look like the part to the right there. Completely compressed, all white space gone, all local variables are A, B, and C, and so on. But you need to figure out exactly in what order to load those files. Otherwise, you will start accessing things that are not declared yet, and so on. You might also want to separate out third-party code here, because that code might not change as often as your own code. So you want to be able to cache it a bit harder. The goal of doing this, concatenating and minimizing your JavaScript code, is of course to minimize the number of HTTP requests you need to get your application running in the browser, and of course minimize also the data that's actually sent over the wire. There are some tools for this. You might know them: Google Closure Compiler, Uglify.js, and the one I'm just going to give a brief demo of here. It's called Requirejs. And it concatenates and minifies with, it actually uses the Closure Compiler and Uglify.js. You can switch between those. So let's just look at what Requirejs does for you. It introduces imports and namespaces in JavaScript. So in this case, I've written some JavaScript code. You see it's supposed to be where the comment is. And that code is dependent on a few other JavaScript files or code snippets. For instance, Backbone. And if you use Requirejs, you start with a call to the require function. You give it an array of the modules that you're dependent on. You open up a function and say what you would like to call them in your own function scope. This is more or less like dependency injection. And then you can start coding. And it means, for instance, that cart model will be referencing the module that's exposed in the file modules/cart model. And just to give you a look of how this looks in the real project here. Let me see. There we go. Yep. And we go here. So this is the actual project, and here you have all of these. You have a main where you start declaring your jQuery, your underscore backbone, your typical frameworks. And then you say what the name of your starting file is for your application. It's called app. So we can go to app. And here you start coding your application. In this case, we start up with opening an application router. We connect to a WebSocket, and we say history start, which means start navigating the application. And then we have our views, we have routes, we have our models. These are data models. So let's look at a cart. This is for buying coffee capsules. So typically you have a delivery address, shipment method. These, of course, reflect the same kind of data model that we have on the back end that we bring out. And if we run this, let's see if we're running right now. I'll just check. So if we run with the regular server here, I'll have to close that one and go here, load. Now we have not done the build yet. So if we now look here, you will see a lot of JavaScript files loaded. And this is not good when you scale up, because each of those files will be a separate HTTP call, and it will take a lot of time before you actually can open your application. But you can use the Requirejs because it actually has full information of all the dependencies. So you can use Requirejs to figure out the exact order you need to have these JavaScript files concatenated into one single file. And in this instance, we start doing a build here. And actually, I cannot have this prepared because it always wipes the distribution folder when I run the vanilla version. So I need to do the build to demo this. And done without errors. And now we can actually look here. There will be a dist. Yep. And if we go to scripts, you will now have an AMD app. And as you can see, it's all in one line, all of the code for the whole, and this scroll bar goes very small, and typically the IDE dies because it tries to parse this. So we close it, and we should be able to finally server dist. And if we now reload, you can see we only have one JavaScript file, all of the code inside. So that's a build world. And by that, I'm actually done.
Thank you, John.